applications using expected value. So first, expected value is the average value of the event, meaning you're playing a game or you're doing something. Each time it's done, what are you going to expect to win or lose? And we find this by taking the sum of the value times the probability for each outcome. Okay, so sometimes I like to make a table so that I can organize this, but let's jump in and see what this looks like. You're playing a game with your friends. It's a dice game. If you roll a 1 or a 2, you lose 5 points. If you roll a 3, you do not win or lose any points. You just stay the same. If you roll a 4 or a 5, you win 3 points. And if you roll a 6, you win 10 points. What is the expected value of a single roll? Okay, so now the idea of this is we have to figure out what this looks like. And this is where I like to make a table, okay? Because I'm thinking about I have outcomes and I have probability. Whew. Okay, so if I roll, I'm just going to put the event over here. If I roll a 1 or a 2, I lose 5 points. So the outcome is -5 because I lose 5 points. And what's the probability of that? Well, we have a 6-sided die, and a 1 or a 2, it's 2 of the numbers. So my probability is 2/6. And I'm just going to keep everything in 6th because that'll make the math easier later. Okay, the next one is if I roll a 3, I don't win or lose. So the outcome is 0. The probability of me rolling a 3 is just 1/6 because a 3 is one side of the 6-sided die. My next item is rolling a 4 or a 5. And the outcome is I win 3 points. So that's a +3 of an outcome, and my probability is 2/6. Last but not least, if I roll a 6, I win 10 points. So that's a +10, and the probability is 1/6. So now that I have my table complete, now I can do the multiply, right? So we want the value times the probability. Value is the outcome. So we're going to multiply the outcome times the probability for each line. So -5/1 times 2/6, right? We want the outcome to be a fraction, so we can just multiply straight across. And I get -10/6. For the next line, I have 0 times 1/6, which is just 0. I love multiplying by 0. I have 3/1 times 2/6, and that gives me 6/6. And then last, I have 10/1 times 1/6, which is 10/6. So now I'm going to add these 4 fractions together. Well, 0 is not really a fraction, but -10/6 plus 6/6 plus 10/6. Whew, say that 10 times fast. I know my denominator is going to be a 6, right? So I have -10 plus 6 plus 10. 10's cancel out. I'm left with 6. So 6/6 is the same as 1. So the expected value of a single roll is 1, meaning I would be expected to win 1 point on each roll. Now you can see that's not possible, but this is like the law of large numbers. Over time, I would be expected to win about 1 point per roll. Let's do one more. Your friend made up a game playing with a standard deck of cards. If you draw a face card, you lose 2 points. Okay, let's just make our table while we go. Okay, we'll come back to probability. Our face card, you lose 2 points. Drawing a 10 neither wins nor loses points. Any card number 2 through 9 wins 1 point, and drawing an ace wins 5 points. What is the expected value? Okay, a standard deck of cards has 52 cards in it. That means my denominator in all of these probabilities is going to be 52. Okay, standard deck of cards has hearts, diamonds, clubs, and spades. And they have ace, 2, 3, all the way up to 10, and then jack, queen, king for all 4 of these. Okay, that means there's 4 of each of these items. Jacks, queens, and kings all have people on them, so those are face cards. So there are 4 jacks, 4 queens, 4 kings. There are 12 face cards. There are 4 tens. There are 4 aces, and then 2 through 9, well, how many is that? 2, 3, 4, 5, 6, 7, 8, 9. That's 8 numbers, right? 2 through 9 is 8 numbers. So if there's 4 each and there's 8 of them, that means there are 32 cards numbered 2 through 9. Okay, so these are going to be the numerators in our probability, right? Because there are 12 out of 52 face cards, 4 out of 52 tens, 32 out of 52 number 2 through 9, and 4 aces. And now I can multiply across. So I'm going to have negative 2 over 1 times 12 over 52, giving me negative 24 over 52. 0 times 4 over 52 is 0. I get 32 over 52 when I multiply by 1. And when I multiply by 5, I get 20 over 52. So now I'm adding. I just add the numerators, again, because all my denominators are 52. So negative 24 plus 32 plus 20 gives me a numerator of 28 with a denominator of 52. Now, both of these are divisible by 4, so I can reduce that to be 7/13, which is about 0.54. So if I'm playing this game, each time I pick a card, my expected value would be to win about a half a point. Again, this is over time, not because we can't just win. Well, we can win 1 point, but we can't win a half a point. So they're saying on average, you will win about a half a point every time you pick a card.